So after the test, we went through and we graphed the sine and cosine functions. All we did was we talked about what were their values. So for sine, this was my angle. And then if you're looking at coordinate points x, comma, y, what was sine? For my unit circle, which value is sine? Y. So basically, you're just going around the unit circle and you're plotting those points. We also said, what was the amplitude for these guys? 1. What was the period length? 2 pi. So what I do to graph this, I start with this idea. I say, okay, my amplitude is 1. So I'm going to go from my neutral line, I'm going to go up 1. And I have a hard time tracking because all the lines on the page gets my eyes a little confused. So I draw guidelines. So I say at the top is 1, and at the bottom is -1. So up 1 and down 1 from wherever your middle line is going to be. Then I said, okay, my period was 2 pi. We don't need to plot every single point, every single angle on our unit circle. There are basically 5 points that we need to plot. And we do that by breaking our period into 5 sections. And we do that by dividing by 4. So 2 pi over 4 gives me what? Pi over 2. So each section that we're drawing here is going to be pi over 2. So that means I'm going to be dealing with points starting at 0, every pi over 2. So that's 1 half, 2 halves, 3 halves, 4 halves. 1, 2, 3, 4, 5 points. And what's really nice about that is these are the places where I'm going to put my specific points, my specific values. And we start by saying, where does sine start? Did sine start top, middle, or bottom? Middle, because the sine of 0 was 0. What was the sine of pi over 2? 1. Sine of pi? 0. Sine of 3 pi over 2? -1. And sine of 2 pi? Those are really the only points I care about. And then it's just a matter of, can you actually draw waves? Not V's, not straight lines, but actual waves. And in all honesty, the answer to that question for me is depends upon which way I hold my paper. So I have to hold my paper sideways. And there, my dears, is my absolutely lovely sine graph. What's extremely important here, well, it's all very important, but you have to put arrows at the beginning and end of your wave. And how you draw your arrows is going to tell me what's going on. Because I'm going to have a lot of people that are accidentally going to make a little whoop, curve up and put their arrow here. Or whoop, curve down and put their arrow here. And that's going to make your problem wrong. So we're coming straight through. We keep on going down. Keep on going up on this side. That is 1 period for your sine graph. Okay? You don't need to put all the points. Tops, middles, and bottoms. Taking that same approach to cosine. We said, what is the amplitude of a cosine? 1. So I'm going to draw my guidelines. You do not have to draw these guidelines. I just know what I need. And I know that if I don't draw these lines, there's no way I'm going to put all of the dots in the right spot. I'm kind of special that way. And we say for cosine, what was the period? 2 pi. So I take my period and divide it by 4. So that tells me each section is again pi over 2. So start, pi over 2, pi, 3 pi over 2, 2 pi. And the last thing we need to do is draw our waves. So what is the cosine of 0? 1. Cosine starts at that top there. Cosine of pi over 2. Good. Cosine of pi. Cosine of 3 pi over 2. And cosine of 2 pi. So if you're one of those folks that were having trouble memorizing the unit circle, if you can remember that sine starts in the middle and cosine starts at the top, that actually might help you remember, oh, sine of 0 is 0. Cosine of 0 is 1. And help you figure out those values. All of this backs each other up. So again, I'm going to draw my curves. I'm going to draw them as curves, not as straight lines. And this is actually one of those things where it's easier to draw when it's smaller. It's hard to draw the bigger it gets. So you guys are lucky. You got the little graphs. I got this big old honking thing. And then for the cosine graph, you see how my arrows point down from the top. Those are your parent functions for sine and cosine. The steps that I used, again, for all of this, I found my amplitude. I used that to go up and down from my neutral line. I took my period. I divided it by 4 to find my sections. And then I said sine starts in the middle and goes up. Cosine starts at the top, and the only place to go is down. Sinusoidal. And you want me to write that down? That is sinusoidal. One of those few English words that actually is spelled the way it sounds. Sinusoidal. And that just means wave-like. All right, so what we're doing today is these are our parent functions. We're going to do our transformations on those functions. I want you to recall, when we're looking at a function, if something is inside the parentheses, which direction does it go? Like your changes. Do they go up and down or left to right? They go left to right, and they go, Theo, one more time. Opposite. So I'm going to go left or right, the opposite. If it is outside the parentheses, which direction does that go? Up and down, and it is the same. Nothing is changing. This directly following the sign is considered inside your parentheses. That A is considered outside. What that does is that says that my amplitude, which is the vertical movement, the up and down, the vertical is your amplitude. So whatever A is, that is your amplitude. Remembering that positive goes up, negative goes down. Now, if it's inside the parentheses, that affects left to right. Which characteristic on my wave is left to right? The period. And inside does the same or the opposite? Opposite. So that means our period changes to 2 pi over b. That right there is the biggest stuff. For every sine and cosine, our amplitude is that number out in front, the A. Our period is 2 pi divided by whatever that number is. If that number is a fraction, we times by the reciprocal. Okay. Best way to do these is just do it. Let's do this. Yeah, buddy. All right, don't let this get intimidating. Even if you may have struggled with your parent functions in the past, these guys are actually kind of nice. It's not all that weird stuff that happens when we're dealing with the like step functions or piecewise or logs. It's really not. It's just top, middle, bottom, up or down from there. So when we take a problem, we start by looking at your amplitude. My amplitude here is going to be 2. And the amplitude, of course, it's not a good idea to start with a problem where both numbers are the same. That number out in front affects your amplitude. So far, so good? Now, you don't need to, but I like to think, okay, up 2, down 2. If you are good at lining up and telling where you're supposed to be, you don't need to draw these lines. A lot of people don't. Every single time I try to do it without these lines, I mess it up. My eyes are like, nope, don't want to do that. What is the normal period for a function? 2 pi. So we take 2 pi, and in this case, I'm going to divide it by 2. This 2. So what is 2 pi divided by 2? Pi. That means my whole period should fit within that window. You don't need to draw that. I'm just kind of making a point. So I should be able to have 1 period here and 1 period here. For every time that you're doing a period, I want you to calculate your sections. To calculate your section, take your period and divide it by 4. That means I start 0, over pi over 4, over pi over 4, over pi over 4, over pi over 4. Look, 1, 2, 3, 4, 5. Those are my points. Keep going, and every time you graph this, you must always fill your graph from 0 to 2 pi. A little bit beyond in either direction to make sure you know which way it's going. This is a sine graph. Will it start top, middle, or bottom? Middle. Is sine going to go up or down? Up. So middle, then I go over to my first line, up. My second one is middle. Third one is down. Middle again. Then you keep on with that pattern. Top, middle, bottom, middle. And the most annoying part, try to draw curves. And always go a little bit past, show us what's happening after that point. After that point there, it's going up. After this point here, it's going down. Yep, you must always fill that entire graph, which is really why you've got this massive packet of papers, because they're kind of funky graphs. It's a lot easier to deal with them like that. And I want you guys to see something. You see how this number here is 2? Inside my B is 2? That's how many periods I should see in this window. 1, 2 periods. So it's a nice way to check, am I doing this right? So far, so good? Let's do another one. Steps are always the same. What is your amplitude for this one? -1. And if my amplitude is negative, what do you think that's going to do to my graph? It's going to flip it. Hey, a negative on the outside does what to your graph? Flips it over the x-axis. That's not changing. The rules are still the same. All right, for my period, I always take 2 pi and I divide it by this number here. So 2 pi divided by 1/2, that is just frankly nasty. So instead of doing it that way, what do? Multiply by the reciprocal. So what is your period? 4 pi. How do we get our sections? Divide by 4. So this divided by 4 is just pi. It's all the information I need to pull from my equation before I get started. So my amplitude is 1. You know what? I'm not going to be able to tell which line you drew first. I'm going to draw 1. And I draw the other side. Because technically the amplitude is just 1, and amplitude is a distance. It's not really a direction, but we do use that negative to kind of help us. My period is 4 pi, so each section is pi. So I start pi over and pi over. And this here is where I'm starting. No shifting or anything like that yet. We'll get to that in a second. Sine. Where does sine start? Top, middle, or bottom? Middle. Sine typically goes up or down. Up. What am I going to do? Why? Because it's negative. So it's here and then here. So when I graph this guy, be very, very careful because this problem is one that I see so many people turning it down here. Middle lines, you go through those. How much of my period can I see? Only 1/2. Okay, so nice little reminders, backups, what the hex. Make sure we're doing that right. Really, the way that I make this the hardest is the way I've made anything hard in this class, is just by messing with your numbers. The concept is not going to change. Looking at number 3, what is your amplitude for number 3? 1/4. Or 0.25 because it's a graph and it's measured in decimals for that, so okay. What is my period going to be with this? 2 pi over 3. Like I said, I can mess with your numbers, and that's what makes this difficult. If my period is 2 pi over 3, each section, how do I go from a period to a section? Divide by 4. Dividing by 4 is the same thing as what? Multiply by 1/4. And if I were to multiply by 1/4, 2 goes into 4 how many times? So that'll be pi over 6. Yeah, it's going to be a teeny wee itty bitty graph. Yours even more so. Neener, neener, neener. We have the top line. We have the bottom line. Up 0.25, down 0.25. These lines, you see how my vertical lines are not spaced evenly? It's not like quarter, a half. Everything's a half. That's because this is pi over 6. So for my sections, that's 1 pi over 6, 2 pi over 6, 3 pi over 6 is pi over 2, 4, 5, 6 pi over 6 is pi, 7, 8, 9 pi over 6, 10, 11, 12 pi over 6. So each of those lines are where I'm going to be drawing this. Sine starts where? In the middle. Does it go up or down? Up here, because we are positive. So up, middle, bottom, middle, top, middle, bottom, middle, top, middle, bottom, middle. Actually, like I said, I think it's a lot easier. Almost the smaller these graphs are, the easier they are to draw. Yes, sir. I'm sorry, can you repeat that? No. We, no matter what, always fill out from 0 to 2 pi. Yes, one period is going to finish at 2 pi over 3, which would be this window right here is one period. But no matter what, you have to take it out. And hey, how many periods should I see on this graph? 3. That number is how many periods I should see. So that's 1, 2, 3. Got 3 periods in there. Any other questions on what we're doing so far? So we start with your amplitude, determine your period, go from your period to the sections, and then think sine or cosine. Sine starts middle, cosine starts where? Top. All right, I want you guys to do number 4. On your own, start to finish. It's almost exactly what we've seen before. I don't know about you, but I like these a lot better than I like logs and exponents. Check your answer with your neighbor if you think you've got it. Yes, sir. Quickly. See some people still drawing. No, you'll have one more quiz on Wednesday. Yeah. Actually, no, Friday. Well, it's not next class. Don't worry about it. We'll talk. Okay? Don't freak out until I tell you to freak out. Yes, ma'am. Friday will be flex something 7. Wait, no, today is 3-6. Wednesday will be something 7. Flex Friday will be 1-2. Yeah. So today is 3-6. Wednesday's 4-7. Yeah. All right, let's take a look at what your answers should have been. Same characteristics as that first sine function. Only this time it was cosine. Cosine starts top. And you might want to think, hey, there's that 2. So check to make sure 1, 2 periods. You wouldn't believe how many people go straight from the top to the bottom to the top to the bottom on accident. Yes, ma'am. Uh-huh. You do. We only did that for this one because that was 1/2 here. So it's always 2 pi over whatever that number is. Right. So this is 2 pi over 2. This one was 2 pi over 3. And when we did 2 pi over 1/2, we multiplied it by the reciprocal to make it easier. Okay? Anybody else? Sweet. Let's just keep going. Keep on keeping on. I want you guys to do number 5 for me, please. If you feel comfortable, go ahead and try number 6, but 6 is going to just have some funky numbers. Want to make sure that we're all on the same page with it. Here we go. Take hints from the problem itself. What number is next to x? 1. How many periods should I see on my graph? 4. Just kidding. Just looking to see if you're paying attention. 1. You should only see 1. All right. I asked you to hold off on this one for a reason. Amplitude is not the reason. What's the amplitude? Negative 1/2. So I'm going to be going up to 1/2 and down to 1/2. But it's negative, and that means where am I going to start? I'm going to start at the bottom. What is my period going to be here? Pi over 2. Everybody okay with why the period is pi over 2? Because if I take 2 pi over 4, that's what I get. Which means, what is my section going to be? Pi over 8. Take a look at your graph. You don't have pi over 8, do you? You have 0, pi over 6, pi over 4. Where would pi over 8 be? Halfway to pi over 4. So that's 0. That's pi over 4. In the middle is going to be your pi over 8. Pi over 2 in the middle. 3 pi over 4, middle. Pi, middle. So just kind of be putting a point in the middle of those. Not on that other line, because that other line is pi over 6s, or pi over 3s. And you told me already, where's my cosine going to start? Negative 1/2. And that means it'll go bottom, middle, top, middle, bottom, middle, top, middle, on and on, and on like Donkey Kong. And we just draw it. How many periods should I see in this whole thing? Come on, how many? 4. Wake up, peeps. You got this. 1, 2, 3. Woohoo! I did it right. 4 periods. The way I make this icky is with those fractions. I would like you guys to do number 7 and 8 on your own, together, whatever, but I want you doing those. Let's take a look at the answers here. Where's my pose? So here's problem number 7. Problem number 7, each section was pi over 6. Hayden, what's your question? Because that was a confuzzled look on your face. Okay. Do you have questions? Anybody got questions? I see a lot of people up and downing it. I see 1, 2, 3, cosine periods. I don't know what that was. Yes. No. Okay. Well, these lines represent your unit circle angles. So that means this first line is pi over 6, pi over 4, pi over 3, pi over 2. And so when we're doing pi over 6s, that's 1 pi over 6. It's basically the lines that are not the pi over 4s. So that means it's this line here. This one here is going to be, that's pi over 2, so that's 4 pi over 6 or 2 pi over 3, 5 pi over 6, pi, those lines. Okay? And then on number 8, kind of a weird one looking. I only see a third of my graph. Each section is 3 pi over 2. You look like a ski slope. I got the best comebacks, don't I? I know you are, but what am I? Yes. No! Yes, I can. And then I will go back to 8 for all of those you want 8. It's a very interesting way to open it. No, I just thought it was funny. Do you have questions on that, Crystal? I know, it's so annoying. It's like all of a sudden, a lot of people will skip a middle and go from bottom to top, and then everything else gets weird. That's why I want you looking at what this is, because you can go back and make a quick check. Do I have 3 full periods? And if not, what did I do? Go back and find your mistake. Oh, yeah. It's so much fun. Yes, sir. Nope. I'm going to skip it. You're going to have to figure it out on your own. Yes. We're not done. Look what time it is. We've got like a half hour more. Wow, that was an interesting sound. Okay. It's the sound of agony. Lord. The only thing that we're changing here, ladies and gentlemen, is going to be the starting place. Okay. Now, here's a little piece of instructions. This is very important. No matter what, if there is a multiplier within the function, in other words, if there is a times, if there's a number between the sine or the cosine and the x, if there is a number in there, you must factor that out before you determine your shifts, because that's just your left, right, up, and down. Again, those rules are going to be exactly the same as what we did for other transformational graphing. So when you see something like this, this is good. This is my amplitude. My period is 2 pi over b. So that's that. Inside the parenthesis moves you which direction? Left to right. And it's the opposite, correct? And outside the parenthesis is up and down. Sometimes it will start by looking like this. If you have a number between your sine and your x, you must start by factoring that number out, which means to just divide that by that number and see what you get. You have to do that. We didn't really do these for the other functions because it was kind of messy, but with the sine and cosines, it works not too bad. What I mean, let's start with this sine function here. What is the number to the left of the sine? 1. So my amplitude's 1. Is there a number hanging off the end over here? No. So that means I am going nowhere up and down. Then I can draw my line. My amplitude is 1, so I'm just going to continue drawing my amplitude like I did before. Up 1, down 1. If you think that line is a waste of time, good for you. Not all of us are that good. Is there a number between my sine and my x? No. What number is there then? 1. So what is my period? Just 2 pi. There's no number between them. That means my b is 1. Hey, there's no number between them. I don't have to factor anything out. This then tells me, which direction do I go? Right. How much? Pi over 2. That means my start is going to be right here. That's where my graph will start. Yes, you do. You do, because a wave goes in both directions. That's where my graph is going to start. My period is 2 pi. What is each section? Pi over 2. So pi over 2, another pi over 2, another pi over 2, another pi over 2, and then you got to back it up. Sine starts where? Top, middle, or bottom? Middle. So on this piece here, start right there. Sine goes up or down? Up. Middle, down. And then if I'm going to back up, this one, is it going to be top, middle, or bottom? Down, because you want to continue the pattern. And that actually looks like what? It looks like a negative cosine graph. But we've done it perfectly. Questions on this one? Abso-freaking-lutely. You kidding me? I'm not setting you on your own yet. Cruel and unusual that would be. Speaking like Yoda, I am. All right. What is your amplitude on problem number 10? -1. Let's just think about the verticals, the up and down stuff. Negative was on the outside. What else is on the outside? A -1 at the end. What is that going to do to your graph? Moves your graph down 1. That means my middle line is going to start down 1. So that's the middle of my graph. My amplitude goes up 1 and down 1 from there. I'm going to kind of not draw it on the black so you can see it there. And then down 1 is here. Is there a number between your sine and your x? Yes. What number is between the sine and the x? 1/2. That means b is 1/2. What would your period be? 4 pi. How big would each section be? Are you okay with that? Staying the same rules as what we had before. The number between your sine and your variable, that is your b. So the only thing we have left to worry about is the left to right shifts. When you figure out what your b is, you have to pull that out of your parentheses. This is the hardest thing you do. You have to pull that out. So it'll be 1/2 times x. And you can either think 1/2 times what gives me pi, Or you can think pi divided by a half. To divide by a fraction means multiply by the reciprocal. So pi divided by 1/2 is 2 pi. You can also think 1/2 of 2 pi is pi. So which direction is my period going to shift? Left 2 pi. This gets a little tricky because if I move my starting point, left 2 pi is way off the graph. I can't go to the end of the period because that's way, way, way off the graph. What you can do is you can think this is going to be a negative sine graph. So it will start top, middle, or bottom, middle, and it will go up or down. I'm just sketching this. So I know that's my full period. Everybody okay on what I just did there? And since my full period goes from 0 to 4 pi, the middle spot would be 2 pi, this would be 3 pi, this would be pi. I am going to shift each of those points left 2 pi. So that's going to be off my graph, right? Pi minus 2 pi. What is that? Negative pi. That's off my graph. What is 2 pi minus 2 pi? 0. So that's where my axis is going to be. So at 0, am I top, middle, or bottom? Middle. 3 pi minus 2 pi? So at pi, I am top, middle, or bottom? 4 pi minus 2 pi? 2 pi, I'm in the middle. Or, as long as you know what your sections are, you can think top, middle, bottom. The reason why we've shifted the whole graph 2 pi, so rather than starting here, we're starting here and going up. I do this a lot. This helps me. I'm a very visual person, so I need to kind of see what's going on. If you can do that in your head and understand where that's going to be, that's perfectly fine. I need this. I have to see what I'm trying to do. That to me is the most difficult part. It's about as hard as the problems get right there. I want you guys to do number 11 on your own. No funky numbers on this one. No factoring on that one. So it shouldn't be the end of the world. It's the end of the world as we know it. I feel fine. I like what I see when you guys check your answers with each other. See some happy faces. That means either we all got it right or we all got it wrong. All right, let's take a look at this. With these graphs, there are a whole bunch of different ways that you can think about them. Because it's a wave and it keeps repeating the same period over and over and over again, once you have your period length, if I cannot shift left, because I'm off the screen, I can go to the end of what my period would have been 2 pi and shift left there. And so when I did this, I used this as my starting point. And then I did my sections off of that. You could have said left would have been out here. So this would have been my top. That means this is going to be the middle. And worked like that. Doesn't matter. It's a wave. It repeats the process over and over and over again. How do we do with that? Do you have questions? Only questions I answer are the ones you actually ask. It's weird how that works out. Okay, let's do this next one together. Lot going on here. I just want to make sure that we're all in the same spot. We'll start it off together to get it set up, and then you guys can graph it. What should you do very, very first with this problem? Factor. Factor out what? The 2. I need to factor out that 2. And when I do that, I would have 2 times x plus, factoring out 2 is the same thing as dividing by 2, so plus what? Pi over 2. With that done, what is my amplitude? Negative 1.5. My other vertical thing. What is my vertical shift? I'm going to be moving up 0.5. What is my period going to be? Pi. Which means each section is going to be how big? Pi over 4. And am I going to be shifting left or right at all? Which direction? Left or right? Left. How much? Pi over 2. The vertical stuff to me is the easiest, so that's where I would start. I would start with my vertical shift, says to go up a half. And then I would do my amplitude. So what's the highest point going to be? 2. 1.5 plus 0.5 is 2. What's my lowest spot going to be? 1, because 0.5 down 1.5 is just 1, negative 1. Now my period was pi. Everybody okay with that? My period is pi, so I can either think about this spot here, or this spot here, or even this spot here. All of those are on period markers. And I'm going to move it which direction? Back pi over 2. Can I move this one back pi over 2? No, he's off the graph. Can I move this back pi over 2? Yeah, so I'm going to move this right here, and this is going to become my starting point. And from that, I'm going to mark my section. So you find your start, then you do your section. So each section is pi over 4. That's those guys. I got to go back the other way also because you've got to fill that whole window. Where is this going to start, top, middle, or bottom? Why is it starting at the bottom? Because it's negative and it's a cosine. So down here. And as soon as I have that 1 point, I know where to go. Middle, top, middle, bottom, middle, top, and backwards. Trying super hard to draw curves and not just V's. I'm not very good at doing this without turning my page, and I'm trying not to turn my page. Yes, sir. If it was left pi over 2, then that would be over here. And cosine would have been negative, so it would have been down here, pi over 4, 0. Okay? That's why sometimes what I do is I'll think instead of where the first one ends, I will go to what my second period would start at and move that. And if that doesn't work, then I sketch out my whole period and just do the subtraction or the addition to figure out where they're supposed to go. So again, what I said, if you weren't listening, we typically start at 0, 0. If my shift goes left and I can't do that, my next step is to say, okay, well, where would the period have ended? And then I would have moved that piece back. If even that doesn't work, I sketch out my practice graph. Like I did before, I would say, okay, this is a negative cosine, so it will go like this. And I would have said the period is pi, so that would have been 0, pi, pi over 2, and so those are my pi over 4s. And then I would have subtracted pi over 2 from each of those. That's my steps from easiest to hardest. I say the easiest is just to move that start. If you can't do that, I move where the next period would have been. If I can't do that, I think about the whole graph. So take that into consideration when you do 13, and then you go and do number 14. And those are the last problems we're going to do today. Okay? Whoa, that's really wonky. So there's number 13. What I did is I said the period is pi over 2. And it was a right shift 3 pi over 2. It says, hey, I can move something to the right 3 pi over 2. So I did that. Here's 3 pi over 2. That's where I'm going to start. From there, each section was pi over 8. And pi over 8 is halfway between the over 2s and the over 4s. And sine goes up. Middle up. Really wouldn't recommend you guys doing these in pen unless your pen's erasable. Questions on number 13? Okay, number 14. Kind of weird. This guy didn't have a left to right shift, but its period was a little strange. The period was 3 pi. It means each section is 3 pi over 4, so we've got to be able to handle those fractions. So 1, 2, 3 pi over 4. 1, 2, 3 pi over 4. Those are where my sections are, and I'm just going to kind of guesstimate where they're going to go from there. Questions? Nobody? In your handouts that I gave you, the next 2 pages, so it'll be on the, let's see here. So it'll be on the back and then the front. Those are your homework. So your homework is homework sine and cosine graphs. There are 16 problems. For some of you, the copier went kind of crummy. So these are all posted on Canvas if you can't quite tell what the numbers are. All right? Through 16. So it's the back and then the whole front of the next page. Again, you will not have a quiz over this next class. Next class, we're going to practice a little bit more with sine and cosine, and then we go on to tangent and cotangent. See you later!